This lab is to study buoyant force. We have three objects: wood block, iron cylinder, and aluminum cylinder. And this is a force probe, and that's connected to the Vernier software. Right now, and let's measure the weight of this cylinder. That's going to be 1.04 Newton. Now the cylinder is fully submerged in water. Let's read the weight this time. Now it's 0.663. You can see the weight is obviously is much less than the weight when it's outside. And the difference, that's because of the buoyant force from water. Here is a free body diagram of the cylinder. You have there is the weight and there is the tension in the string. That's the current weight. And the difference of that number, that's going to be the magnitude of the buoyant force. And the buoyant force always point upward. And according to Archimedes Principle, and the buoyant force is going to be equal to the weight of water being displaced. And today we're going to test this theory. So we can find the buoyant force from this calculation, and the weight of the water being displaced is a mass density multiplied volume. That's mass multiplied G. So this is going to be the volume of water being displaced. Now if I put the cylinder in water, you can see the water level rise up. So by reading the difference, the initial volume of the water and the final level, we can find the volume of water being displaced. And for this one, this is about 40 milliliter. Now, because the cylinder is fully submerged in water, therefore the volume of the cylinder itself is going to be equal to the volume of water being displaced. And therefore this number, they are the same. So this is the volume of the block itself. So we're going to repeat this one for the other three objects. Now let's look at the wood block. The wood block just float, and then the string is loose. Therefore, the tension in the string, that's just going to be 0. By reading the graduated cylinder, we can find the volume of water being displaced, and given the density of water, 1,000 kilogram per cubic meter, multiply volume, so make sure convert the volume millimeter to cubic meter, and multiply the free fall acceleration g, you can find the weight of the water being displaced. So these two should be very close. And you have noticed that some of the objects will float like the wood block. Some of the objects will sink to the bottom like the cylinder. And that's up to the density. So if the density of the object is greater than the density of the fluid, it will sink. If the density is lower than the density of the fluid, it's going to float. So we want to find out the density so that you can compare the density of the block with the density of water. And in this lab, we don't require a lab report, and this is the worksheet. And you finish the worksheet and take a photo or scan this paper, submit on Blackboard.